This video is going to cover question 2, part B from the 2022 free response AP Calculus AB Calculator Required section. I broke this question up into 4 separate videos just because it really is 4 separate topics and they don't coalesce with each other. So it's better, if you're looking for one or the other to just kind of go through them individually. So this one's going to be about part B. So let's dive in. We're being told here that on this given interval, h of x, this new equation, is the vertical distance between graph f and g. And they want to know, is h increasing or decreasing at x equals negative 0.5? So as soon as you see that type of language, as soon as you see somebody talking to you about increasing or decreasing, you know that what you're doing is going to be a first derivative game. Because first derivatives, wherever our first derivative is positive, that tells us that our graph is increasing. Wherever our first derivative is negative, that tells us where our graph is decreasing. So really what this question is asking us to find right now is it wants to know what is h prime of negative 0.5. And we're just looking for a positive negative here, right? Because that will tell us if this thing is increasing or decreasing. Well, the great news for us is this is going to be pretty straightforward, especially since we've got a calculator to use. So first and foremost, though, we got to have an equation for h of x. So h of x is the vertical distance. It's the gap in between these two functions here. So between f of x, which is the natural log of x plus 3. We found that out in the first video just by graphing the two equations. And then this bottom one is our g of x equation. That's x to the 4th plus 2x cubed. Again, we found that information out. If there's anything that does carry on from a previous video, it's just the fact that we know which equation is which from just putting them into the y equals on our calculator. So if you haven't done that already, you would just put this into y1. You'd put the other equation into y2, and then that would let you know once you graphed those which of these two equations was the top equation and the bottom equation. And why that matters is when you need to find the gap, the distance between two equations, it's oftentimes you think about it as the height, but when you need the distance between two equations, it's really just like finding the area between the curve and the x-axis. Except they're two different curves. So what you do to find the height is you're just going to take whichever equation is on top and you're going to subtract off whichever equation is on bottom. So it's like that. It's like on question part A, where we were finding the region between these two curves, and we did top minus bottom. Here, that's just how you find the distance between two equations. So for us on this one, we would be looking at a top equation is going to be the natural log of x plus 3. And then we're going to subtract off of that. And when you subtract, make sure you put minus parentheses because we are going to be subtracting that full equation. If you do not put that parentheses in, you are definitely not going to get the right answer. You'll be off by a sign. And now that we know that, what we know is we're trying to figure out what is h prime of negative 0.5 equal. So we can do this in the calculator nicely enough. What we can do is we're going to take this and we're going to pop this into y1 on our calculator. Then from there we would graph this. And then we will do a second calc. And in the calc menu, we're going to choose the number 6 option, dy dx, because we want the derivative at a point. And then we're going to type in the x value that we care about. So on this problem, the x value is negative 0.5. And at the bottom of the screen, once we hit enter, it's going to say dy dx equals, and whatever that is, that's our h prime of negative 0.5 value that we're looking for. So open up our calculator. Again, kind of the nice thing is we have that in the calculator already because we just used that on part A to find out what the integral was. This time we're using the same exact equation, except we're using it in a different way. We're trying to see the derivative of this at a point. So we're going to now just hit second. Oops, let's graph it first, excuse me. So we'll graph it, and then we will hit second calc. This time we want to find the derivative, so we're going to hit option 6, dy dx, we'll hit enter on that. Then we type in the x value we care about. So we want it at negative 0.5. We type that in, and at the bottom of the screen there, you'll see that it says dy dx equals negative 0.6. So here, we really didn't care about the number. We more care the fact that this is negative. It is negative 0.6, and because it's negative, that's going to tell us that it is decreasing at that x value. So it's decreasing at x equals negative 0.5. So this question would have been 2 points value on the test. They would have given you a point for understanding that this was what you needed to do, sort of linked together with your setup for the equation. And then they would have given you 1 point here for getting out the right answer. So 1 point for understanding that the derivative was what you were looking for, and 1 point for getting the right answer. And we'll follow up 2 more videos to do part C and part D. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.